Hello aspirants. In the last lecture, we learned about single displacement reaction. That is the part 1 of displacement reaction. Today we are going to learn about the double displacement reaction, second part of the displacement reaction. So let's start the topic. Before learn about the double displacement reaction, that is a definition, in most of the books you will get double decomposition reaction. Okay students, I will say in the later of this video that why double displacement reaction is also known as double decomposition reaction. Okay students, but there's another name for double displacement reaction, that is salt metathesis reaction. Now what metathesis mean in chemistry language? Let's know about it. See students, the what metathesis mean in salt metathesis reaction is, see students, the word metathesis means the exchange of radicals or element of a molecule with other molecule to form a new molecule. Why I write both radicals and element? Because elements. Because metathesis reaction takes place both for the ionic compound and as well as for the covalent compound. So for the ionic compound it will be exchange of radicals, and for the covalent compound it will be exchange of elements. Okay students, and sometimes molecule also, not molecule, elements only, of a molecule with other molecule, it will exchange each other's radicals or elements to form a new molecule. Okay students, from this theory, means from this concept only, double displacement reaction come. Okay, the main foundation is metathesis. Now why salt metathesis reaction? Because we are going to learn to study about the ionic compounds only. That's why salt metathesis reaction, salt. And in sometimes covalent salt, sorry, not covalent, covalent compounds which behave like salt, in that reaction, that is in the organic reaction, we will see the salt metathesis reaction also. But for today we are going to learn about the double displacement reaction. Okay, that is the exchange of radicals between the ionic compounds. Now students, let's move with the definition of the double displacement reaction. See here, it states that the chemical reaction involving the exchange of radicals between two reacting chemical species, which results in the formation of new products with similar or identical bonding affiliations. See, before starting about double displacement reaction, let me clear a doubt that why double displacement reaction named. See, only the two compounds will exchange each other radical or the bond, okay, bond species. That's why two, that's why the from that, in this reaction only two compounds involved, that's why double displacement reaction. But in higher studies, when we will study about the salt metathesis reaction, we will see more than two compounds also react with each others, means and exchange their radicals to form the new compounds. Okay students, Now see, which results in the formation of new products with similar or identical bonding affiliations. This is very important. See, the chemical reaction involving the exchange of radicals. Now what is radicals? Radicals are the can be atom, molecule, or as well as atom, or as well as ions. Ions is very important, which has the unpaired electron or electron shell. That is not a paired, means it is in the ions, in the form of ions only. Okay, now I told that it can be in the form of atoms also. See, Cl2, it can be ion also, Cl minus, or free radical. In organic chemistry we learn about the free radical reaction. That time we will denote Cl minus. That time we will not write Cl minus during the free radical reaction. We will represent like this, Cl and one dot at the head of the Cl. Okay, this represents the free radical. Okay, that means in this chlorine unpaired electron is present. Okay, these are the radicals such as NH4 plus, SO4 2 minus. These are radicals. Okay, it will react between two chemical species which results in the formation of new products. Two reacting chemical species, that's why two products will form new product with similar or identical bonding affiliations. Means the bonds of the chemical species in the reactant side can have the same chemical bonding in the product side, or identical bonding can be also present. That means the chemical bonding in the product side is not similar with the reactant side. That's why identical bonding affiliations. Okay students, now let's see the general equation. General equation for the double displacement reaction. AB plus CD, it will form AC plus BD. Okay, students, understand? Now we will see the different types of double displacement reaction. Basically there are three types. First one is formation of precipitate. Means double displacement reaction with respect to the formation of precipitate. Second one is formation of gas, and third one is formation of molecular compound. Now first one, formation of precipitate. One of the product will be formed as precipitate, and from that concept only double decomposition reaction named. See, in the decomposition reaction we see that it will decompose. It can be gas also, or as well as precipitate in the form of precipitate also. Yes students, from that concept only double decomposition reaction named. Third one is formation of gas. One of the compound, means one of the product will be gaseous in the form of gas. Okay, it will take place in the gaseous form. And the third one is formation of molecular compound. See, all are will form molecule, but in this it will not formed as precipitate also or as gas also. Both the compound should be in the aqueous form only. Okay students, that's why formation molecular compound. The state should be same, but new product will be formed. Okay. Now students understand that why double displacement reaction is also known as double decomposition reaction, only because of the formation of precipitate, nothing else. In basically in the older days only, double decomposition reaction is only known for the salt metathesis reaction. That time it is not termed as double displacement reaction, because on the older days most of the reaction takes place in the formation of precipitate. Precipitate means what? One of the compound will not dissolve in water. Yes, it will formed as solid compound, and in formation of solid is only the decomposed position of the compound. It is decomposed. Yes, that's why formation of solid takes place. Solid compound, that is the ion or the ligand. What is ligand? You will learn in the higher class. The ion of the reactant, the ions of the reactant exchange and form a solid compound. Okay students, now understand that why double decomposition reaction is also known for the double displacement reaction. Now move with an example, not one, we will see is some of the important reactions. First, start with the precipitate reaction. See, silver nitrate plus NaCl. These all are in the aqueous form. Okay students, it will form sodium nitrate and AgCl, silver chloride. Okay, it will formed as precipitate and it is white PPT. PPT is the abbreviation for the precipitate, and this is downwards arrow is the symbol for the precipitation. See, basically AgCl doesn't soluble in water, it is insoluble salt. That's why when the ions is exchange each other in the reactant side, it forms NaNO3 in aqueous form, and this ionic compound, this ionic salt formed as the solid, since it is not dissolved in water. And why it is not dissolved in water? Basically the lattice energy, means formation energy, is much higher than the formation energy of water. So for the water it is not possible to break down this AgCl and making it a aqueous solution of silver chloride. That's why AgCl takes place in the solid form and precipitate it, and as a result, how will you understand that AgCl is there? Means AgCl is formed because in this reaction you will get white PPT. Okay students, and that white PPT is nothing, that is AgCl. Barium chloride, when reacts with sodium sulfate, or barium sulfate, precipitate and sodium chloride, it is also white in color. calcium chloride when reacts with carbonic acid H2CO3. It is carbonic acid. It forms calcium carbonate and 2 moles of HCl. It is also white in color. Let's see some other examples of double displacement reaction. Now see in this example, PbNO3 whole 2 when reacts with Ki, it forms PbI2, lead iodide. It is in yellow in color. The precipitate of PbI2 is yellow in color and KNO3. See what happens. In aqueous medium, Pb2 plus and NO3 minus. Yes, it will form ions. Same in aqueous solution of Ki, K plus, I minus. See what happens when they react each other. This Pb2 plus takes I2, I minus. Yes, and this K plus takes NO3 minus and forms new product, that is PbI2 and KNO3. When PbI2 forms, the precipitate of the color is yellow. Okay students, now understand that how the ions takes place, means exchange of the ions. Now see the other examples. Now here is a funda in this reaction. This is also a precipitate reaction, but one of the compound is in the gaseous medium. See, this FeSO4 is aqueous and it is green in color, that is pale green. Okay, this H2A gas, it is in this H2S, it is in the gaseous form. Okay students, we will take FeSO4 in a test tube and we will inject H2S gas, okay, with the help of Krebs apparatus. What is Krebs apparatus? You will learn about Krebs apparatus. Means the Krebs reaction means reaction that needs H2S gas. With that help of Krebs apparatus, you will give H2A gas in FeSO4. Okay, and FeS will form as well as H2SO4. See, H2SO4 is always in the aqueous medium only. Yes, so it will not be in precipitate form. This FeS will be in solid state, and that means it will precipitate. And what is the color of FeS? Black. Okay students, understand ferric sulfate. Sorry students, iron sulfide. See another reaction with the help of H2S gas. When CuSO4, that is blue in color. Okay students, when reacts with H2S gas, it gives CuS and H2SO4. It is black in color. Now you may ask me that when we are injecting H2S gas in other aqueous medium compound, it will form black PPT. The answer is no. See one example. When ZnSO4 reacts with H2S gas, it gives ZnS and H2SO4. This ZnS is white in color. Okay students, understand? but except H2S gas we can inject other gas also. When ZnSO4 reacts with Na2S, it is also in gaseous medium. Same reaction, ZnS and Na2SO4. This is also white in color. Okay students, understand? Now move towards the reaction that involve the formation of gas, that is one of the compound, one of the product is in the gaseous form. Let's see. Chemical reaction means double displacement reaction in which gas is formed. See the first example. When sodium sulfite, now this is in aqueous form, when reacts with HCl. Okay students, when Na2S reacts with HCl, it form NaCl. See, sodium will take chlorine ion, that is chloride, and H2S gas will form. See, one of the compound is in gaseous form. Another example, zinc sulfide. When ZnS reacts with HCl, it forms ZnCl2, yes, and H2S gas. Okay students, understand that what is the formation of, means double displacement reaction with respect to the formation of gas. Now the third one, that is double displacement reaction with respect to the formation of molecular compound. See, that is nothing, we will learn about it in next video in neutralization reaction, basically acid base reaction. I am showing one. When HCl reacts with sodium hydroxide, see both are in aqueous medium. Now what will happen? It will form NaCl and H2O. This one is in aqueous form and this one is in liquid form. Yes, basically H2 is liquid only. See, no precipitate, no gaseous form. Both the compounds in product is in aqueous form. Yes, and what happens? New molecular form, but no precipitation, no gaseous form, only two new compound form, and this is only the formation of the molecular compound. We will see in the next video, that means in the neutralization reaction, when we will learn about the neutralization reaction, basically acid base reaction. Okay students, for today up to this much. Hope you enjoyed the video. If any doubt is there, please comment me, and please like the video, share with your friends, and also don't forget to subscribe our channel Vivekananda Vigyan Charcha. Thank you. See you in the next video.